Welcome to D-Link Academy tutorial. In this video we will learn to add SSID with minimal configuration to AP profile and overview the available radio configuration options. To begin, go to Configure, Access Point, Profiles, click on SSID under Action column of desired profile, for example DBA@academy. These are the existing SSID to this profile. Click Add SSID to add another one. Give it a name, say Hello People. The name cannot be more than 32 characters. Select band of your need. You can select both or one or none. We select both and click Save. The added SSID will be automatically sorted alphabetically. We will configure security and others later. You may have noticed that adding SSID requires only 3 clicks. Push the configuration to broadcast the new SSID. You can add at most 16 SSIDs per profile, that is 8 SSIDs per wireless band. You make a note that you must have at least one SSID to an AP profile. Now let us see the available configurations of radio. Radio has 3 subtabs: Basic, Channel and Advanced. Basic radio configuration includes enabling or disabling of either 2.4 GHz band or 5 GHz band or both. Radio can be operated in various 802.11 standards. Depending upon the number of mobile devices, we can adjust channel bandwidth to optimize throughput. For range, you can adjust transmitting power between 2% to 100% of 20 dBm. To prevent mobile devices on different SSIDs of same network from seeing each other, enable SSID isolation. Channel subtab has configurations related to radio channels. To automatically scan the local area and assign devices to the optimal wireless channel, enable auto channel mode. But if you want to fix the channel, then disable it and choose one from this drop-down option. For now, we will proceed with auto channel enable. The available channels may vary depending on the country of operation. To cope country's compliance, enable or disable a channel by clicking on it. Forcing to auto channel scan is more accurate, but wireless clients may be disconnected during the scan. Specify the interval in hours at which the auto channel scan is performed. Perform auto channel scan instantly by clicking Run Auto Channel Now. The advanced subtab is related to multicast rate, beacon interval, DTM interval, UAPSD, and short-guard interval on radios. Beacon broadcast interval is the time lag between each of the beacons sent by the access point. Let us illustrate beacon interval with animation and discuss its pros and cons. In the illustration, we have AP and mobile devices. The orange circle represents radio's wave with the beacon, which will be broadcasted at certain interval. I will broadcast the beacon at an interval of 100 milliseconds. You can observe the beacon broadcast frequency. Now I will change the beacon interval to 500 milliseconds. You can observe that the frequency of the beacon broadcast relatively decreases. This is the definition of beacon interval. These 3 figures illustrate beacon broadcasting at an intervals 100 milliseconds, 200 milliseconds, and 300 milliseconds. The mobile device can sleep in between the beacon interval, meaning longer the beacon interval, longer the device can sleep. The shorter beacon interval facilitates VoIP, roaming, and relatively better performance with weak signal, at the cost of bandwidth and mobile battery life. The longer beacon interval uses relatively less AP bandwidth for broadcast, so higher throughput. Mobile goes for longer sleep, so less power consumption and relatively longer battery life. But why do we need beacon broadcasting? The beacon is needed for mobile devices to receive information like SSID, timestamp, and other parameters about the access point. Default beacon interval for Nuclias AP is 100 milliseconds, which can be set up to 3500 milliseconds. DTM is Delivery Traffic Indication Map or message. According to the name, SS point with DTM message buffers the traffic for later delivery. When any device associated with the SS point has 802.11 power save mode enabled, the AP buffers all multicast frames and sends them only after the next DTM beacon, which may be every 1, 2, or 3 beacons, determined by DTM interval. In the illustration, there are 3 figures, which is at beacon interval of 100 milliseconds and different DTM interval of 1, 2, and 3. For same DTM interval, when I change beacon interval to 200 milliseconds, the mobile devices get longer sleep. With the change in beacon interval and DTM interval, the sleep time also changes. Thus, with the proper adjustment between beacon interval and DTM interval, you can optimize bandwidth, throughput, mobile battery life, etc. The DTM interval can be adjusted between 1 to 255. On scheduled automatic power save delivery, UAPSD is a power save mechanism for mobile devices connected to UAPSD supported AP. Actually, some applications like VoIP and live video generate a predefined number of packets periodically. Example, VoIP generates every 20 milliseconds. So UAPSD let mobile devices to be at sleep mode after the packet delivered and before the packets are generated. It may save power of mobile devices up to 400%. Guard intervals are used to ensure that distinct transmissions do not interfere with one another, that is, to prevent inter-symbol interference. The default guard interval for 802.11 is 800 nanoseconds, and to enhance the throughput, a short guard interval of 400 nanoseconds can be adopted by enabling short guard interval. This is all about brief on adding SSID and overview of radio configuration in Nuclias Cloud. We learned that with the proper adjustment to radio parameters, we can optimize throughput. For better performance, be aware of your network. Thank you for watching. For more educational videos, please visit D-Link Academy.